Imagine vast clouds of gas and dust scattered across the universe, glowing with colors that tell stories of birth, death, and rebirth. These are nebulas, cosmic masterpieces that shape the very fabric of our universe. In this video, we'll explore what nebulas are, how they form, and why they matter in the grand cosmic story. What exactly is a nebula? A nebula is essentially a massive, interstellar cloud of gas, dust, and plasma found in galaxies across the universe. While some nebulas are regions where stars are forming, others are the byproducts of stars that have died and expelled their outer layers into space. Nebulas are often vast in size, spanning dozens to hundreds of light years across. Their beauty, structure, and purpose in the cosmos make them some of the most intriguing astronomical objects. How do nebulas form? Star formation regions. Nebulas often form in the densest regions of molecular clouds, also called giant molecular clouds. Gravity causes parts of these clouds to collapse, compressing the material until nuclear fusion begins, giving birth to stars. The process often creates clusters of stars, as one collapsing region triggers others nearby. Dying stars. Low-mass stars. When stars like our Sun reach the end of their lives, they shed their outer layers, creating planetary nebulas. Massive stars. When a large star explodes in a supernova, the expelled material forms stunning structures called supernova remnants. Collisions. Collisions between clouds of gas or even galaxies can compress gas, triggering the formation of new stars and nebulas. Nebulas are primarily composed of hydrogen. The most abundant element in the universe exists mostly in molecular H2 or ionized forms. Helium, the second most abundant element. Dust particles, tiny solid grains of elements like carbon, silicon, and oxygen. Ionized elements, these give nebulas their bright colors when energized by nearby stars or other energy sources. For instance, oxygen emits green light. Hydrogen often appears red. Helium and reflected starlight appear blue. Different types of nebulas and their roles. Emission nebulas. Emission nebulas, like the Orion Nebula, glow brightly because the gases inside them are ionized by nearby stars. They're usually red or pink and are active regions when new stars are born. Then we have reflection nebulas, such as the Pleiades Nebula, which don't produce their own light but reflect the light of nearby stars. They appear bluish because blue light scatters more easily. Dark nebulas. Dark nebulas, like the famous Horsehead Nebula, are thick clouds of gas and dust that block light, making them look like dark patches against brighter backgrounds. These are dense with material and are key areas for star formation. Planetary nebulas. Planetary nebulas, such as the Ring Nebula, are formed when a dying star sheds its outer layers. They enrich the galaxy with important elements like carbon and oxygen, named because they appeared round like planets in early telescopes. Supernova remnants. Lastly, there are supernova remnants like the Crab Nebula, which are created when massive stars explode. These remnants spread heavy elements like gold and iron throughout the universe. Each type of nebula not only looks incredible, but also plays a crucial role in the life cycle of stars and the enrichment of the cosmos. How do nebulas influence star and planet formation? Nebulas are like cosmic nurseries where stars are born. Inside dense areas of a nebula, called molecular clouds, gravity starts pulling gas and dust together. This creates something called a protostar, essentially a baby star that hasn't fully formed yet. Now, here's where it gets interesting. Not all the gas and dust gets sucked into the star. The leftover material forms a spinning disk around the young star called an accretion disk. Over time, parts of this disk clump together and stick, eventually forming planets, moons, and other objects like asteroids. So, without nebulas, we wouldn't have the raw materials to form stars or the planets that orbit them. Our solar system, including Earth, started out in one of these star-forming nebulas. Billions of years ago, iconic nebulas you should know. Orion Nebula, M42. It's a huge region where new stars are being born. It's the closest star-forming nebula to Earth, about 1,344 light-years away. You can even see it with the naked eye in the Orion constellation. It looks like a bright, fuzzy patch. Eagle Nebula, M16 distance, 5,700 light-years away. This nebula is famous for the pillars of creation, towering clouds of gas and dust where stars form. The Hubble Space Telescope captured an iconic image of it, making it world-famous. Crab Nebula, M1 distance, 6,500 light-years away. This is the leftover material from a massive star explosion, a supernova, that people on Earth saw happen back in 1054 AD. It's still glowing and expanding today. Helix Nebula, distance 650 light-years away. It's often called the Eye of God because it looks like a giant, colorful eye in space. This nebula was formed from the outer layers of a dying star. Carina Nebula, distance 8,500 light-years away. This nebula is home to some of the largest and most short-lived stars in the galaxy. These stars are so big and unstable that they'll explode as supernovas relatively soon in cosmic terms. Each nebula tells a story about the life and death of stars. The role of nebulas in cosmic recycling. Stars are born. Nebulas are like cosmic nurseries. They're made up of gas and dust. And when gravity pulls this material together, it forms new stars. So, nebulas give birth to stars. Stars eject material. Stars don't last forever. When they reach the end of their life, especially the big ones, they explode in a supernova or shed their outer layers. This is called a stellar wind. This process releases enriched gas and dust, which contains heavy elements like carbon, oxygen, and iron. Next generation. The gas and dust that stars eject get scattered into space, and eventually they can be pulled back together to form new stars, planets, and other objects. This cycle continues with each new generation of stars and planets being built from the remnants of the previous ones. So, nebulas are not only where stars are born, but they also help recycle the materials that make up new stars and planets, ensuring that the process of star and planet formation continues over time. Thanks for watching. If you learned something new or just loved the visuals, don't forget to hit like, subscribe to join our cosmic community, and turn on the bell icon so you don't miss out on our next adventure.